Welcome to today's lecture on the Tweed Merrifield system in orthodontics. In this session, we'll look at the foundation of edgewise mechanics, wire progression, the three orders of bends, the concept of the 10-2 Anchorage system, and finally the principle of directional force control. Remember, orthodontics is not just about straight teeth. It's about controlling forces to shape both occlusion and the face. Neutral Edgewise Bracket. This is the neutral edgewise bracket, the foundation of the Tweed Merrifield approach. It has a slot measuring 0.022 by 0.028 inches. The neutral design means it begins with no built-in prescriptions, so all tooth movements are expressed through the bends placed in the wire. This gives the orthodontist complete control of tooth position, but also demands greater skill in wire bending. Wire sequence. Treatment is staged with a logical wire sequence. We begin with small, flexible wires, typically round nickel titanium, to align and level without overwhelming the periodontal ligament. As alignment improves, we progress to larger, stiffer, rectangular stainless steel wires. These wires fill the bracket slot more completely, allowing precise control of torque and angulation. Think of it as moving from gentle guidance to firm architectural support. Orders of bends. To control teeth in 3 dimensions, the orthodontist introduces first, second, and third order bends into the wire. First order bends are in and out adjustments, moving teeth buccally or lingually. Second order bends control crown angulation, tipping teeth mesially or distally. Third order bends provide torque, the root inclination relative to the crown. An analogy is driving. First order bends are like steering left or right, second order bends are like tilting the wheels, and third order bends are like adjusting suspension for proper grip on the road. 10-2 Anchorage System. Merrifield emphasized controlled, sequential tooth movement rather than moving the entire arch at once. This is the 10-2 Anchorage system. 10 teeth are used as stable anchors, while only 2 teeth are actively moved at a time. This minimizes anchorage loss and allows for very precise movement. For example, retracting canines against a strong posterior anchor unit prevents molars drifting forward. The result is better arch form and more predictable outcomes. Finally, directional force control is the principle that truly connects orthodontics to facial aesthetics. Forces applied upward and forward create balanced faces, upright incisors, stronger chins, and stable smiles. Forces directed downward and backward lengthen the lower face, produce gummy smiles, and may lead to lip incompetence. In other words, the direction of orthodontic force literally determines the fate of the face. This is why Merrifield's system was not just about tooth movement, but about facial balance. Conclusion. To summarize, the neutral edgewise bracket with a 0.022 by 0.028 slot provides a clean mechanical foundation. Wire progression moves from light, flexible alignment to stiff, precise finishing. First, second, and third order bends give us full 3-dimensional control of tooth position. The 10-2 Anchorage system ensures efficiency and prevents anchorage loss. And directional force control reminds us that orthodontics is as much about the face as it is about the teeth. Thank you for your attention. Now let's apply these principles clinically.